Hello, classmates. Today I'm going to be talking to you about STEM education, and I'm going to be focusing on some issues that face STEM education today and also some issues that face STEM educators. As a little bit of background, I am a math and science teacher. My certification is general science 5th through 12th, and then also biology 9th through 12th. And so I have about 4 years experience teaching life and physical science and earth science at the middle school level. So this is a topic I've thought a lot about but haven't done a whole lot of research on. So I'm excited to share with you. Before we dive into all of the issues, I wanted to talk about what STEM is, because I think teachers don't have an accurate maybe understanding of what STEM is meant to be. This is a quote that I liked. It says, STEM is a curriculum based on the idea of educating students in 4 disciplines, science, technology, engineering, and math, but in an interdisciplinary and applied approach. Rather than teach the 4 disciplines as separate, STEM integrates them into a cohesive learning paradigm based on real-world applications. So a lot of times when I hear STEM education, I just think, okay, well, that means that the school has, some good science and math courses. But I didn't realize that when people refer to STEM education, they're actually talking about an integrated and applied approach to learning math and science. Science and math at most schools, what that means is that there are specific courses of study in biology, chemistry, and physics. And it means that there's also specific courses of study in Algebra 1, 2, Geometry, and Pre-Calc or Calculus if you have more advanced program. But STEM education should integrate these 2 courses of study with engineering and technology. And that's where things get kind of sticky. All schools offer science and math. But as far as integrating those topics into engineering and technology, most fall short. And the reason why is that people don't really have or teachers don't have an adequate understanding of what's meant by teaching engineering and technology. Engineering is applying science and math to solve problems. Engineers figure out how things work and find practical uses for scientific discoveries. Scientists and inventors also often get the credit for innovations that advance the human conditions, but it's usually engineers who actually make the innovations available to the world. For example, one example I think is really good is that penicillin was actually discovered in 1928 by Alexander Fleming, but it would be almost another 15 years before engineers were able to problem solve and figure out how this new breakthrough could be actually mass produced in a way that would make it available to the wider world. Technologies are the products of engineering. I think at least for me, I had this idea that technology in the classroom means that you use your iPad or you use some kind of machine when you're teaching the kids. But that's actually the exact opposite of what's meant. A technology is meant to be the product of an engineering project. So it's not that the kids are supposed to use tech while they're exploring STEM. It's that they're supposed to be creating a technology that can be used to solve a real world problem. There are a lot of unique challenges that come with being a STEM educator. As I said, there is a misunderstanding about what is meant by engineering and technology. A lot of science teachers just think that, as long as you are using an iPad and you're, trying to integrate some kind of technological advance into the science class, that means that you are doing engineering and technology. In addition to that, there's really inadequate teacher training and support, and that's across the board in math and science. Let me show you over here. 10 to 20% of middle and high school STEM teachers aren't even certified in their content area. And that's true. As a STEM educator, I can tell you that is absolutely the case. In addition to that, just in general across the board, it's really essential for science teachers to get practice with like running labs, designing labs, and there's a lot of specific pedagogy that goes into science teaching, but almost no teachers receive any preparation that's content specific to teaching science, technology, engineering, or math. When it comes to the T and the E part of STEM, most teacher prep requires no courses in engineering, and that includes, if you know, even if you're a teacher who has a bachelor's degree in biology or chemistry, you still probably have not taken any engineering courses. And certainly if you're doing a teacher certification course, you would never take a class in engineering. And yet it's thought that, you know, or it's expected that if you're a science teacher, somehow you will be teaching the kids to do engineering. It's kind of unrealistic. This last quote is great. It says, engineering and technology, because they're applied, are elusive subjects for academically minded people who don't have an industrial background. You know, as someone that's taken a lot of science, I can tell you that my understanding of science is adequate and sufficient to teach students from a textbook, or, you know, even from lab experiences and all of that, but I have no experience in engineering at all. And it's not because I'm stupid, it's because none of my education was geared toward that. And I think that's pretty typical for most, certainly most people who are getting a bachelor's degree. Unless they got a degree in engineering, they really haven't done any of it. And so to ask people to teach engineering then is, like I said, unrealistic. Another issue specific to STEM teaching is that there's not adequate pay or teacher incentive to attract and then retain good STEM teachers. So in general, there are much fewer teachers who graduate from teacher training courses who have a STEM certification of any kind. And the reason for that is because there are pretty stiff wage penalties for people who choose to go into teaching STEM rather than just going into a STEM field. These are a couple of great quotes, and I will go ahead and read them just because I think they really highlight the issue. The first one says, most conversations fail to acknowledge that teacher wage penalties differ quite markedly between teachers of different disciplines. Individuals with degrees in science, technology, engineering, and math are hit the hardest when they choose to enter teaching over other careers in their field. So one way that some have thought this would be a good way to fix this problem is to pay bonuses or higher salaries for STEM teachers to offset the wage penalty. But, you know, this is unpopular with teachers' unions because they want everyone to be paid the same, and so that kind of goes against the whole idea of unions. But this is a huge issue. My mom, for example, is a chemistry teacher. She has an undergrad degree in chemistry and a master's degree, and she almost has another master's degree in earth science. And, you know, she teaches AP physics, she teaches AP chemistry. She spends hours and hours and hours and hours doing labs and researching and doing, you know, continuing education and how to teach these AP courses. And she makes the same amount of money as a kindergarten teacher. And, you know, kindergarten teachers are professionals and they need to be paid like professionals. But there is a huge difference between what she could make as a chemist and what she is currently making as a very low paid employee in public education. And it's a huge issue. This kind of shows that in chart form. This is a estimated teacher pay penalty by undergraduate major. And you can see that people that graduate in a STEM major will make more by not teaching at every single point in their career. And it's pretty steep. This line shows non-STEM majors, and there's still a teacher pay penalty, no matter what your major is. But if you're a STEM major, it's even more. And so it's pretty hard to convince people that could go on to become a chemical engineer that really what they should do is take a low-paying job at a public high school instead. So, having said that, there are some policy issues that are part of the problem. One of them is that there's a lack of accountability. So, even though there's standardized testing for math and English and social studies, there really isn't one for science. The NGSS and Common Core have kind of tried to step in to provide at least some guidelines for what's supposed to be taught in science, but in general, STEM subjects are not very well defined. And if you go to either NGSS or Common Core and look at the standards, it's pretty mushy in terms of, especially engineering and technology, what it is exactly that the kids are supposed to be doing and learning. The other policy issue, as I said before, is that currently in America, at least, all teachers are paid exactly the same. But if you're a STEM graduate, you make more than STEM educators, a lot more. So one way that this is being approached is that some schools are offering like alternative certification for people who are in science fields who would like to teach instead of continuing with their lab science or their engineering or whatever they were doing before. At my son's school, there's several teachers that have taken this route. One of them is a retired doctor. He finished with his medical practice and wanted to teach, and so he used an alternate certification route to be able to do that. Another way is differential pay, which, again, as I said, that goes against everything the unions stand for, but it is definitely a solution. And some states are putting that into practice, especially for hard to staff STEM topics, like especially physics and chemistry. And then lastly, there is something called the STEM Master Teachers Corps, which has not yet been fully funded, but the idea is that it will be like a group of teachers that will participate in high quality professional development. It's a way that master teachers can be identified, but then not just identified and rewarded, but actually used to help younger teachers learn how to teach science and math. Culturally, integrating science, technology, engineering, and math can be a great thing, especially if you have a teacher who's familiar with the cultural background of the students. It always improves student learning if the instruction is culturally relevant, and there's lots of opportunities for that to happen, especially if you integrate STEM. So, here's some different pictures. But these kids are actually solving a community problem that's relevant to their life. And so STEM has a lot of promise, especially in making science culturally relevant to every population. It's been shown that making STEM culturally relevant benefits every student, not just those that are from minority backgrounds.